A formula is a ratio of one element to another. For ionic compounds, it is the simplest ratio of cations to anions. Since each cation is surrounded by anions, there is never just one cation like sodium and one anion like chloride. It is millions of them side by side, but it is the simplest ratio called the formula unit that is reported as the formula for an ionic compound. So for sodium chloride, it's 1 sodium to 1 chloride. In covalent compounds, their formulas are the exact number of each atom present. So each molecule of carbon dioxide is exactly 1 carbon atom bound to 2 oxygen atoms. For each molecule of glucose, it is 6 carbon atoms bound to 12 hydrogens and 6 oxygens. This is the compound's molecular formula, the exact number of each atom present in the compound. If we were to simplify it to the simplest ratio of one atom to another, it would be the compound's empirical formula. For carbon dioxide, the ratio of 1 to 2 is as simple as it can get. But if we look back at glucose, you can pull out a 6 and simplify it down to 1 to 2 to 1. So glucose's empirical formula would be C1H2O1, while its molecular formula would be C6H12O6. Going from a molecular formula to an empirical formula is therefore relatively easy. Simply find the lowest common denominator and pull it out. If we were asked to go from the empirical formula to the molecular formula, it's a bit more complicated. Since a whole number was pulled out, we'll need to find a whole number to put back in. Looking at the formulas is not going to give us any sort of clue. However, when we pulled out a number, we also lowered the compound's molar mass by a whole number. The number, therefore, that was pulled out is the ratio of the molecular formula's molar mass to the empirical formula's molar mass. So we'll divide the molecular formula's molar mass, which we will have either found in a previous segment or was given to us, by the empirical formula's molar mass. Redistribute the number into the empirical formula, and we'll have our compound's molecular formula. Often we'll be given a compound's percent by mass and asked for its empirical formula. To do that, we'll remember a poem written by Miss Freeman of Menschville High School. The poem is as follows: percent to mass, mass to mole, divide by small, multiply till whole. Percent to mass means that we'll first assume that we have a 100-gram sample. So if we have a compound that's 43% phosphorus and 56% oxygen, if we had 100 grams, 43 grams of it would be phosphorus and 56 grams would be oxygen. In short, we'll simply change the percent signs to grams. In mass to mole, we'll find the number of moles of each element in the compound by dividing the mass by their molar masses, giving us 1.4 moles of phosphorus and 3.5 moles of oxygen. For divide by small, we'll look for the simplest ratio of one element to another by dividing by the smallest number of moles. Since we only have 1.5 moles of phosphorus, we'll divide both of these numbers by 1.5. Lastly, our ratio should pan out to whole numbers, or very near whole numbers. If they do not, multiply all the numbers by 2. If that doesn't work, multiply by 3, and 4, then 5, until you end up with all whole numbers, or very near whole numbers. Since we didn't get near a whole number when we divided by the moles of phosphorus, we'll multiply all of our numbers by 2. So when we do so, we find that we have 2 phosphorus for every 4.99 oxygen, which is very near 5. So our empirical formula for this compound will be P2O5, or diphosphorus pentoxide. The least electronegative atom always goes first, with the exception of hydrogen. If you have to multiply by any number more than 5, chances are you have made some error in a previous step. Go back and double check yourself. Thanks for watching. In our next video, we'll talk about balancing chemical reactions. If there's something we mentioned in this video that you didn't quite understand, perhaps it was in our previous video, diatomic molecules and percent composition. Special thanks to the following websites for their clip art and cartoons. Please don't sue me, I'm just a teacher. Also, a special thanks to Renee McCormick of the National Math and Science Initiative for her videos, which I have done a very poor job of boiling down to under 5-minute segments, as well as her curriculum and notes. A link to her videos and the notes can be found in the description below. See you next time.